Hello students, hope you all are doing well and you all are also studying well. Welcome to this video. So in connection with probability and its simple terms we discussed in the previous video, we will move ahead with something called as a priori probability. So what we had spoken about in the last video was about random experiment. So that experiment is a statistical process which can be repeated and you never know about its result or about its outcome. That is called as the random experiment. And then every outcome of that random experiment is called as the event. Okay. So for example, tossing of a coin is a random experiment. Then getting head or tail can be the event of that random experiment. And we have two types of events. Those are simple and composite event. Composite event are made up of multiple events. Simple events is it's a single event which cannot be divided further. And all the events or all the possible outcomes of one random experiment are grouped together into something called as a sample space. So these are the things we discussed. Then we also discussed about the summation of events as well as the product of events. Suppose there are two events A1 and A2, then their summation A1 plus A2, that means either A1 occurs or A2 occurs. And when it is product of A1 A2, that probability that means A1 and A2 occurs both of them occurs at the same time. Okay. Now what do you mean by priori probability? Now why it is called as priori probability? So talking about probability or their outcomes, for that statistical experiment or that process has to be done at large number of times. Okay, so that experiment is already done, that one particular coin was tossed multiple times or 100 or more than 100 times, and how many times it was giving head and how many times it was giving tail, those statistics is done, and then it came to the conclusion that there are 50% chances of head and there are 50% chances of tail. That the entire theory of probability is based on this concept, that every outcome has equal number of chances. So if it is head and tail for one coin, both of them have same number of chances, and coin is not biased towards head or tail. So on this base, this entire probability theory is built. Okay, so now for example, if you take the rolling of one dice, then for every one of them has got the equal probability or equal number of chances, that is 1 divided by 6. So every outcome is given or every outcome is believed to be having the same number of chances. Out of all the outcomes of the entire experiment, each outcome has the same number of chances. On this base, on this foundation only, theory of probability is based on, or theory of probability is built. Okay, so now priori probability means the same thing, that after doing those many experiments, then only that conclusion came that for one particular coin or for any one coin, the head and tail have same probability or same chances. So now mathematically, how do you represent a priori probability? Okay, so now suppose there is one random experiment and that is having n number of equally likely, or you can say mutually exclusive outcomes, or you can say events. Suppose there is one particular experiment, random experiment, and it is having total n number of events. N number of total possible outcomes are n, and all those are simple events, they are mutually exclusive, or you can say equally likely events. So the meaning of mutually exclusive means if one event is occurring, then occurrence of that one event, it prevents the occurrence of all remaining other events. Okay, so these are called as the mutually exclusive events. So all such mutually exclusive simple events, there are such n events in one particular experiment, and there are r events, or you can say m also. There are m outcomes in favor of particular event, say A. Okay, if we denote these two things in this way, that there are m outcomes in favor of particular event A and total outcomes are n, then probability of event A is given by m divided by n. So this is how the probability is given. So m is the number of outcomes which are in favor of that particular event. A is that particular event and n is the total outcomes of that random experiment. Okay, so now if you consider the example, suppose there are tickets numbered from 1 to 10 and we need to find the probability of getting ticket numbered as 6. So now from 1 to 10, how many tickets are numbered as 6? There is only one ticket. So there is only one outcome which is in favor of event A, and event A is we are looking for a ticket which is numbered 6. So value of m will be 1 and the equally likely mutually exclusive outcomes. The total outcomes of the entire experiment are all the tickets numbered from 1 to 10 including the number 6 which you are looking for. So n will be 10. Then the substitution becomes 1 divided by 10. Alright. So m is the favorable outcomes in short, for which we have to calculate the probability, and n is the total number of outcomes. So now this way also I can write this way also, that favorable outcomes divided by total outcomes. So this is how you define favorable outcomes divided by total outcomes. So mathematically probability is defined this way, that is favorable outcomes divided by total number of outcomes. So if you have understood the basic formula of calculating probability. Now if you compare it with the examples we had discussed in the previous class, that suppose there are two members in a team of, okay, there are two members in a team and only one of them has to write the exam, then both of them have equal number of chances, because out of two you are going to select one. So your favorable outcomes are only one because we are selecting only one, and then the total outcomes are 2. So 1 by 2 gives you 0.5. So 0.5, that means 50% of chances are there to both of them. And same if you make it 3, then total number changes 3, but you are still selecting only one person. So when you say 1 divided by 3, then that gives you 33.33% of chances. Alright, so this is how we need to calculate the probability. Now as long as we are selecting only one item or we are selecting only one object, then their favorable number of objects and total number of objects are seen very clearly. In the case when we have to do with multiple objects, like among, say there are 10 members and among 10 I am going to choose 2 people. I am going to choose 2 people among 10, then that time the calculation takes a totally different form. So that we will see in the examples when we actually solve them. Now we will focus only on this, that it is simple ratio, that is favorable outcomes divided by the total outcomes. This way we need to understand. Then we'll see some examples on it. Before that we'll prove one theorem, that is the addition of probabilities or addition rule of probability. We'll see how we can apply that theorem. So first we'll have a proof of that theorem. So the addition rule of probability is given this way. So for any two events, say A1 and A2 defined on the same sample space, the addition rule states that probability of A1 plus A2 is equal to probability of A1 plus probability of A2 minus probability of A1 A2 together. Okay, so this is how the addition rule says. It is the same. If you remember the addition rule, the addition principle from set theory. It is the same thing here. Okay, and even in Venn diagram we have represented the events in this way. A1 is one event, A2 is another event, and A1 A2 can be composite event, and there is some common part between A1 and A2. Okay, so that is denoted as A1 A2, where A1 and A2 both of them are occurring at the same time, and there is left out part for A1 and A2 where A1 is occurring but A2 is not occurring. Similarly this side also A2 is occurring but A1 is not occurring. So in the diagram this part will be denoted as A1 occurs but A2 does not occur. The middle part is denoted as A1 A2 both of them occur, and the other part which I have dotted is A1 does not occur but A2 occurs. Okay, so this way it is given. Now from the Venn diagram we will first try to write how can we write the probability of A1 plus A2 where A1 and A2 are occurring. Okay, so then from Venn diagram so let me first write down about the description about it. So the part which is dotted, okay, the shaded part. Okay, so for Venn diagram shaded part is where A1 A2 both occur. Okay, so I have explained the same thing I have written. So from Venn diagram this is what we have understood. Okay, so now if I have to write the probability of so if I have to write the probability of A1 plus A2, then I write it in this way: probability of A1, so then that covers the complete A1 circle. So when you complete that A1 circle, what you are remaining with? You are remaining only with the dotted part. So A1, A2 together when we want, we have to complete both the circles. We have to cover both of them. So now when you say probability of A1, that takes only the first event, complete event. Then only the dotted part has to be considered. That is nothing but only A2 occurs but A1 does not occur. So I'll write it in this way. So I would write it in this way: probability of A2 then A1 bar. A1 bar, that means A1's complement where A1 does not occur. Okay. So this is my equation 1. So probability of A1 plus A2 we have expressed in this way from the Venn diagram, that complete A1 along with its common part of A2, then only part of A2 where A1 does not occur. Alright, then I can also write event A2 now from the Venn diagram how I can write event A2. Okay, so now A2 is having its two parts. One is its exclusive part, another is its common part. So then from Venn diagram I'll be writing A2 this way: the exclusive part of A2 where A1 does not occur, that is A2 and then A1 bar, plus the common part of A2 along with which is also part of A1. So that is considered as A1 A2. Now if you remember the sum of events and product of events. So product of events, that means both of them occurring at the same time, and that is denoted as A1 A2 or any two event 1 event 2, this way. And sum of the products is where either this or both. Okay, but product of the events, that means both of them occur. Okay, so that's why I have written it as A1 A2, and same way we have denoted in the Venn diagram as well. So alright, so this is my equation where I can write A2 as A2 A1 bar plus A1 A2. Okay, then the same I can use to also find its probability. Okay, then probability of A2 can be written this way, that is probability of A2 so it can be written this way, that probability of A2 A1 bar plus probability of A1 A2. Okay, what I have done, I have just added probability here. On both the sides, I have taken their probability. So now, this term, which is A2, A1 bar, present in this or as well. So for this term, we will form an equation that we will substitute in this formula. So then, this term, let me shift on the other side. So what do I get here? Probability of A2. So from this, probability of A2, A1 bar is alright. So I have found the another equation, probability of A2, A1 bar. This I have shifted this side. Okay, no, this is at the same side. I have to shift probability of A1, A2 together on other side. So what do I get here? Probability of A2, A1 bar is probability of A2 minus probability of A1, A2. Now this value I need to substitute in this equation. Then substituting equation 2 in equation 1. So what do we get? So this term we have to substitute. This term we have to substitute as with this. So definitely we get the same proof, that is probability of A1 plus A2 is probability of A1 plus probability of A2 minus probability of A1 A2. So this is how we have proved the theorem, that probability of A1 plus A2 is equals to probability of A1 plus probability of A2 minus probability of A1 A2. So this way we have to prove the theorem by using the equation 2 and substituting into the equation 1. Okay, so hope you have understood this proof of the addition rule of probability. Alright, now the same we can expand for three events as like addition rule, that probability of A1 plus A2 plus A3, then we have to subtract common A1 A2 A2 A1 and A1 A3, and then we have to add at the end that A1 A2 A3. It is the same addition rule what we have used in the set theory. Same rule is applicable. So only the thing is like we have to make use of the probability term here. Okay, so this is proved here. So this completes here proof of the theorem. Okay, now the next thing is, what if A1 and A2 are mutually exclusive event? Okay, if A1 and A2 are mutually exclusive, so if A1 and A2 are mutually exclusive events, then what is the probability of A1 A2? So A1 A2 is what? When A1 and A2 are occurring together. So when A1 and A2 are mutually exclusive, that means if either A1 occurs or A2 occurs, they cannot occur at the same time. Then it is understood that A1 A2 cannot occur same time. So if A1 and A2 are mutually exclusive, then it is understood that probability of A1 A2 is 0. In that case, the addition rule of probability is given by only probability of A1 plus A2 is equals to probability of A1 plus, so it is given by this much, probability of A1 plus probability of A2, and if you subtract probability of A1, A2 together, which is nothing but 0. So this much is the proof for which we have the A1, A2 events which are mutually exclusive. Alright. So addition rule of probability, if you have, hope you have understood. So A1, A2 are the two events. Those two events can be simple or can be composite event. They can be mutually or they cannot be mutually exclusive events. And their addition probability is given in this way, that probability of A1 plus A2 is probability of A1 plus probability of A2 minus their joint probability. Joint in the sense probability of A1 and A2. Alright. Now we'll move forward for some examples in the connecting video.